When both x and y are defined as a function of t, we have a parametric equation. In this video, I am going to talk about my exploration on parametric equations. To explore, I chose the equation x equals 3 times sine 2t, y equals 1.5 times cos t. As you can see, this is a parametric equation because both x and y are defined as a function of t and not defined as a function of each other. The t-min and the t-max can decide where the graph will start and end because they are like the domains of the t-values. They decide how low or how high of a t-value can be plugged into the equation. I am going to choose a t-min of 0 and a t-max of 2 pi, which will make a full rotation of the graph. But when using a graphing calculator, we face a bit of trouble. As you can see, the graph isn't fully drawn. However, in order to explain why, we need to go over the concept of t-steps. T-step is the number that the t-value goes up by when plugging it in the equation. For example, if the t-step is 0.1 and the t-min is 0, we would plug in 0, 0.1, 0.2, 0.3, 0.4, and so on into the t-value. If the t-step is changed to 0.2, since there is a bigger difference in the t-values, the graph plots points further apart so that the resulting graph looks angular, rougher, and not smooth. This is because it has less points to plot. It is drawn faster than before. If the t-step is changed to 0.25, since the difference between the t-values are less, the graph plots points closer together so that the graph looks more smoother than before. This is because it has more points to plot. It is drawn slower than before. Now that we know the concept of t-steps, let's go back to the problem before. T-min of 0 and t-max of 2 pi was supposed to draw a full graph, but it didn't. This is because the t-step is 0.1, and 0.1 doesn't go up to 2 pi, which is approximately 6.28. 0.1 will only go up to 6.2. This is why it doesn't draw the full graph. One thing to note is that by changing the t-min, you are changing the initial point, and by changing the t-max, you are changing the terminal point. This is because when t-min is -1, for example, we start the first point by plugging in -1 to the t-values of the parametric equation. But when t-min is changed to -2, for example, then it is plugging in a different number to the t-values, which will result in different starting points. This is the same for t-max relating to the terminal points as well, where the terminal point will be different if the t-max is changed from, for example, 1 to 2. There are ways to move the graph go anywhere we want. To make the graph shift to the right, I can add the certain amount I want it to move to the end of the x equation. For example, if I add 5 to the end of the x equation, the graph shifts 5 units to the right. To make the graph shift left, I can subtract the certain amount I want it to move to the end of the x equation. For example, if I subtract 5 to the end of the x equation, the graph shifts 5 units to the left. To make the graph shift up, I can add the certain amount I want it to move to the end of the y equation. For example, if I add 5 to the end of the y equation, the graph shifts 5 units up. To make the graph shift down, I can subtract the certain amount I want it to move to the end of the y equation. For example, if I subtract 5 to the end of the y equation, the graph shifts 5 units down. Like the x and y equations of this parametric equation, some equations have a number in front of the equation. By changing this number, the domain changes. The original x equation has a 3 in front, and so the graph's domain goes from -3 to 3. If this changes to 5, then the graph is horizontally stretched, making the domain be from -5 to 5. If the number changes to 1, the graph is horizontally compressed, making the domain be from -1 to 1. The original y equation has a 1.5 in front, and so the graph range goes from -1.5 to 1.5. If this changes to 1, then the graph is vertically compressed, and so the range goes from -1 to 1. If this changes to 2, then the graph is vertically stretched, and so the graph range goes from -2 to 2. Up to now, the direction of the graph being drawn when Tmin is 0 and Tmax is 2 pi was from the top to the right, but there are ways to change the direction. If you plug in a negative in front of the x equation, there is a reflection over the y-axis, so the graph is drawn from the top to the left. If you plug in a negative in front of the y equation, there is a reflection over the x-axis, so the graph is drawn from the bottom to the right. If you plug in a negative in front of both x and y equations, you get a graph that starts from the bottom to the left. To make this parametric equation 3D, we need to add another equation called z. Since we don't have another z equation, we are just going to assume. The graph would look like this if z equals t. The graph would look like this if z equals sine t. An extra information I found from this particular equation was that if I change the number 2 from x equals 3 multiplied by sine 2t, it will create a similar function except with more loops. If I change that number to 4, as you can see, there are 4 loops.